So to wrap up dilations, we're going to talk about kind of a fun little thing, which is what happens if you dilate lines. So first of all, just think about, like, if you took a line that was infinite and you stretched it or shrank it, just kind of think about what might happen. Okay, so let's go through a few examples. If I'm going to dilate this line by 3, so it's going to get 3 times as long, and the center of dilation is the origin, which happens to be on the line. So like we did in the last few examples, let's pick a point like 1, 1, which is on the line. And typically, to get from the center to that point, I would go right 1, up 1. But if I'm going to triple it, I'm going to go right 3, up 3. So right 3, up 3, which, if you'll notice, still lands on the line. Or like, pick a point down here somewhere, just any point, like -2, -2. If I were going to dilate that by a factor of 3, I would again triple it. So instead of going left 2, down 2, I'm going to go left 6 and down 6, because I tripled the 2's there. So if I go left 6 and down 6, notice that I still land on the line. Basically, everything that I do is going to land back on the line. Let's try another one. What happens if I dilate this line here by a factor of 1/2 about the point 1, 1, which is also on the line. It's not the origin, but it is on the line. So again, if I pick a point somewhere else on the line, like 3, 3 here, and let's say I want to cut it in half. So currently, from the center to that point, I go right 2, up 2. If I were to half that, it would be right 1, up 1. So instead of going 2, 2, I'll go 1, 1, but notice that I land still on the line. Same thing with anything over here. Pick like -1, -1 or something on the line, and scale it by 1/2. So instead of going down 2, left 2, I'm going to go down 1, left 1, which is still on the line. So this is probably overkill at this point, but you'll notice, based on these examples, and if you want to keep experimenting, you can, what do you think we can conclude about dilating a line if the center of dilation is on the line? Like, if I were to stretch or shrink this line out from this point, what do you think is going to happen? And so the conclusion is, basically, anytime you dilate a line with the center of dilation directly on the line, the line is unchanged. Okay, so what if we want to dilate the line and the center of dilation is not on the line? So like the point 2, 0. This time we're going to scale it. It's over here. Someone probably took it for him. So in this case, we're going to scale it by 2, but the point 2, 0 is not on the line. So think about what happened with like the triangle and the rectangle when the point of the center of dilation was not on the line. So let's just try it and see what happens. So like, pick a point on the line, maybe like this point. Typically, to get from the center to that point, I go left 2. But if I'm going to double it, I'll go left 4. Or to get to this point, I would go left 1, up 1. If I double it and go left 2, up 2, I land here. Or to get to this point, I go left 3, down 1. If I double that, I'll go left 1, 2, 3, 4, 5, 6, and down 2. If you keep doing this, you'll notice that it actually forms a line like this, which is parallel to the line that we originally had. So you can't really say it's twice as long because it's an infinite line. So if I stretch something that's infinite, it's still infinite. And don't even get me started on the fact that some infinities are bigger than others. It's a very abstract thing. But basically, if you stretch this line by 2, it's going to be a line still. But notice if the point of dilation, the center of dilation is here, the line is not the same line like it was in this case. It's actually been pushed away. Let's try another one. In this case, the center of dilation is at 2, -1, which again is not on the line. In this case, the scale factor is 1/2. So think about what might happen if I scale this line. Again, if it's 1/2 as long, it's still infinite. But do you think it's going to be the same line, further away, still parallel? I don't know. So let's try it and see. So pick some points on the line, maybe like this one. To get from the center to that point, it was left 2, up 1. Since we're doing half of that, I'll go left 1, up 1/2. And then let's pick another point, like this one. It was left 1, 2, 3. Now it's going to be half of that, so like 1.5. Or to get to like this point, it was up 1, 2, 3, 4 over 1. So I'll go up 2 over 1/2. Or to get to this point, it was left 1, up 2. So I'll go left 1/2, up 1. And you'll start to notice all these points are going to look like this. They form a line that is once again parallel, but not exactly on that line. So based on the examples, what do you think you can conclude about dilating lines when the center is off the line? So basically what happens is, if the center is not on the line, it's going to either push the line away or pull it in closer. The line will stay parallel, but if it's a dilation by a factor bigger than 1, it will push the line away. And if it's a scale factor less than 1, like 1/2, it will draw in the shape close, or the line closer. So here's that conclusion. The dilation of a line not passing through the center of dilation results in a parallel line. It's not going to be the exact same line, but it will be parallel. So basically, here's our conclusions. If you dilate a line and the center of dilation is on the line, like here's the line, here's the center of dilation, it's not going to change it. But if you dilate a line and the center of dilation is over here or over here, it's going to either push the line away or draw it in, and so it will be a parallel line. So basically, lines and line segments are always parallel when you dilate them. They either go out or come in, and they form, remember, you can connect a point, the image and the pre-image, and it should lead you to the center of dilation, which makes kind of this cool triangle looking thing that we'll talk more about later. So everything we've done so far has been just lines, which obviously are always infinite. But what if we're talking just about segments? Segments have endpoints. So when you dilate these line segments, they're either going to end up being the same line or a parallel line, but these might actually grow or shrink. So don't overthink this. If you're going to dilate by 1/2, the segment's going to be half as big. This one is dilating about the point -1, 2, -1, 2, which is on the line, meaning it's not going to be parallel, it's going to just grow by 1/2, and it's going to like shrink up directly on the line. Or if it were a bigger scale factor, it would grow out from the line. Again, you just really need to count out from the center of dilation. So instead of going up 2 over 1, I'm just going to cut that in half and go up 1 over 1/2. So that's the new endpoint. And instead of going down 1, 2, 3, 4 over 2, I'll cut that in half and go down 2 over 1. So you can't just guess, you do need to like count and do some math. But there's my new segment, which is half as big as this one. Notice it's not quite in the middle because the center of dilation wasn't in the middle. On this one, we're going to dilate it by 3, so it's going to get 3 times as big, and the center of dilation is here, -1, 0. So in this case, since it's growing and the center of dilation is not on the line, it's going to push it kind of out and away. But you'll see, all you have to do is count again. Instead of going 1, 2, over 1 up 2, I'm going to triple those. So over 1, 2, 3, up 1, 2, 3, 4, 5, 6. And instead of going left 1, up 1, I'll triple that and go left 3, up 3. So that is my new segment, 3 times as long, and it grows out from the center of dilation, so you can see if I were to connect those points, they would go right through the center. So keep in mind, the dilation of a line segment is longer or shorter just according to the ratio given by the scale factor. If the scale factor is 3, it's going to be 3 times as big. If the scale factor is half, it's going to be half as big.